Good morning, class. We are looking at the final exam review covering chapters 2.1 to 6.1. Here's the second part. Example 16. Observations show that the length L in millimeters from nose to tail of a Siberian tiger can be estimated by the function L is equal to 0.25 W to the power of 2.6, where W is the weight of the tiger in kilograms. Furthermore, a young tiger's weight can be estimated in terms of its age, T, in days by the function W equals 3 plus 0.21 T. All right, so the first part, how long is the tiger when it's 100 days old? It's elementary algebra. You plug in the T equals 100 to this formula to find the weight. This is 21 and 3, they add up to 24 kilograms. You put that into the formula for L, you replace the W here with 24, you put it into a calculator, and with a bunch of decimals, 969.369 millimeters, reminding everybody 1000 millimeters is 1 meter, so it's close to 1 meter. So the first part is elementary algebra. The second part, at what rate is the length increasing when it's 100 days old? We are looking at the concept of a Leibniz's notation, dy dt is dy du du dt. So we are interested in the LDT. So what goes in between from L to T in between the variable is W. So dL, dW, dW, dt. So when you differentiate this with respect to W, you get 0.25 times 2.6 W to the power of 1.6. And when you times dW dt, when you differentiate this with respect to T, you get 0.21. And so you multiply these three numbers and you put it first, 0.1365 W to the power of 1.6. Now, when it's 100 days old, you have two choices. You can replace the W with 3 plus 0.21 T and now replace the T with 100. Or because we already know the W from part A is 24 when T is 100, just replace the W with 24. Put it into a calculator and you have the answer. The second method is to find L as a function of T by replacing the W. So L of T is 0.25, parentheses 3 plus 0.21 T to the power of 2.6. And now we are going to find L of 100. So replace the T with 100 here. That's for part A, and it gives you the same answer as we got here. As far as the second part, we want dL dt or L prime of T, which makes it 0.25 times 2.6, the same thing to the power of 1.6, and by the chain rule times 0.21. So again, 0.25 remains, 2.6 sits in front, same thing to the power of 1.6, and 0.21 by the chain rule. Multiply those three numbers, and notice you get the same number here, and instead of W3 plus 0.21 T to the power 1.6. And now if you replace the T with 100, you please understand these two are the same. And when you do that, L prime of 100 is the same thing that we found here. And I hope everybody is comfortable with that. So that was the second method, everybody. Find an equation of a tangent line here. So x e to the power of y plus y e to the power of x equals 1. And at 0, 1, by the way, this happened to be a y-intercept. Now, in order for you to find it, you have to find the derivative and then plug in to find the slope. So we have the pair, we want to find the slope. To do that, we are going to use the product rule here and here. And if you assume this is f times g, then the derivative of this is f prime g plus g prime f. So the derivative of x is 1 times e to the power of y plus the derivative of e to the power of y is also always itself times y prime or dy dx by the chain rule. Imagine it's e to the power of g of x. Okay, everybody? So in essence, we are looking at this one. And then times x by the product rule. So that's the first part. The second part, this one is also f times g. So f prime, or makes it y prime times e to the power of x, y prime times e to the power of x, plus e to the power of x is itself times y. And of course, the right side is a number, any number results in 0. Now, what do you want? You want to solve for y prime. So you're going to keep everything involving y prime, and the other ones move. So this moves, everybody, and this moves, and these two we factor out the y prime. So y prime or dy dx is the right side divided by this parentheses, divided by this one. So we have a pair, now we want the slope. So plug in the pair. So we write it in this manner. M equals y prime evaluated at the given pair. Replace the x, wherever you see x here, with 0 and y with 1. And so we get e to the power of 1 plus e to the power of 0 times 1 over e to the power of 1 times 0 plus e to the power of 0. So let's see what we get. Obviously, this is 0, everybody. And this is 1. So we get e plus 1 over 1. And don't forget there's a negative sign. It doesn't go away. So simply minus e minus 1. And because this is the y-intercept, we are going to use just the easy way out. Y equals mx plus b. So we multiply this one by x and then plus b, which is 1. And we are done. And this is the exact answer, everybody. We want to differentiate this, and we are going to use the product rule by putting a raised dot here. F prime g plus g prime f. So the derivative of e to the power of 2x is always itself. And then by the chain rule times 2, by the product rule times ln x, plus the derivative of ln x is 1 over x by the product rule times e to the power of 2x. And we're done with calculus. We factor the common factor of e to the power of 2x. This gives you 2 ln x. This gives you 1 over x, and you're done. Log base 5 of x squared plus 1. In order to differentiate, first you want to decompose the log. There's nothing you can do, just the way it is. You start differentiating by flipping this over. F prime of x is 1 over x squared plus 1. Then you need the derivative of the argument times 2x. Then you look at the base. If the base is e, you're done. If not, 1 over ln v, so 1 over ln 5. And this, we just rewrite this by putting the 2x in the numerator. If you want to differentiate this, you have to flip this over and then multiply by its derivative, which uses the quotient rule. But you decompose that, ln of the top, ln of 2x minus ln of the bottom. And ln of 2x is ln 2 plus ln x. ln 2 is a number, the derivative is 0, but ln x gives you 1 over x. And this one, minus 1 over 2x plus 1 by the chain rule times 2. And so the x times 2x plus 1 is in common. That is your LCD. 1 times 2x plus 1 minus 2 times x. 2x cancels out the 2x. So the final answer is 1 over x times 2x plus 1 as the final answer. We are done. Logarithmic differentiation, y is x to the power of sine x. Anytime you have a function to the power of some function, logarithmic differentiation is one way to do that. So what does it mean? Number one, take the natural log of both sides. So when I take the natural log of the left side is ln y. When I take the natural log of the right side, I can put the sine x in front. And so now I can differentiate this side and this side. I'm going to do it implicitly, which means ln y gives me 1 over y times y prime. The right side, I use the product rule. Sine gives me cosine times ln x, plus ln x gives me 1 over x times sine x. And I'm practically done because y prime is the right side times y. See, 1 over y. So I got to multiply both sides by 1. So solve dy dx for y prime. Multiply both sides by y. And what was y? Replace it with x to the power of sine x. And again, this is one way to do that. Also, you could rewrite x as e to the power of ln x. And then differentiate it without logarithmic differentiation, which is the e to the power of ln x times sine x, and differentiate it that. Differentiate y equals x times sine inverse of 3x. So first and foremost, let me put a raised dot in between. So the f function is simply x, and the g function is sine inverse. So you want f prime g plus g prime f. So f prime is 1 times sine inverse of 3x. This is g. Now g prime. How do we differentiate the sine inverse? Remember, the sine inverse, if you want to differentiate, is 1 over square root of 1 minus x squared. Cosine is the same thing with the negative. But what happens when it's sine inverse of u or g of x? Okay, then you put du dx square root of 1 minus u squared, square root of 1 minus u squared. So if it's g of x, you simply put g prime here and g of x here. So please understand this is sine inverse of 3x. So this is the function that we are talking about here. You can call it u. Okay, so we're going to use this one because I call this f times u. I don't want to go with that one. So we go with this one. So how do we go with this one? Here's how we write this. Okay, 1 minus u squared. U is 3x, so put it here. And then you want the u dx, which is simply 3. So 3x goes in here, 3 goes in here. And by the product rule, the g prime f times x. Times x. So this is f prime g prime f. You just rewrite it and you're done. X cosine inverse x minus square root of 1 minus x squared. We want to differentiate this. So the very first thing we do, we change this to 1 minus x squared to the power of 1/2. Now we are going to put a raised dot here. So we know that it's f times g, and we're going to use the product rule. X gives me 1 times cosine of inverse. And then cosine of inverse, simply put negative 1 over square root of 1 minus x squared times f, which is x. So that one is done. Now we're going to work on this. To work on this, we're going to pay attention to this format so we can use the extended power rule. In other words, this one. So 1/2 times the same thing to the power of 1/2 minus 1 or negative 1/2. And then by the chain rule times g prime of x, the derivative of this piece is negative 2x. Done with calculus. Let's rewrite this. So this is clearly cosine inverse x. This one is minus x over square root of 1 minus x squared. I want you to see what happens to this one. First of all, negative 1/2 and negative 2, they give you positive 1. And secondly, this whole thing is simply x divided by 1 minus x squared to the power of 1/2, which is the square root. And so these two cancel each other. Final answer is cosine inverse of x. The distance in meters of an object from a starting point is given by s of t equals 2t squared minus 5t plus 4, where t is time in seconds. What is the velocity of the object from 2 to 4 seconds? This is the average velocity. This is elementary algebra. So s of 4 minus s of 2 over 4 minus 2, which means you plug in 4, you plug in 2, you do the math. So this is 2 times 4 squared minus 5 times 4 plus 40, and this one is 2 times 2 squared minus 5 times 2 plus 40. The difference and divided by 2 gives you 7 meters per second. That is elementary algebra. This is the part which is calculus. What is the instantaneous velocity and acceleration of the object? What is the velocity and acceleration of the object after 6 seconds? V of t is s prime of t, which is 4t minus 5. After 6 seconds, replace it 4 times 6 minus 5, makes it 19 meters per second. Acceleration is the second derivative of the position function, so take the derivative again, or the first derivative of the velocity function. So when you take the derivative again, you simply get 4, and 4 happen to be a constant. That means after 6 seconds or 5 seconds or 10 seconds, it makes no difference. And the units are meters per square second, because A of t, I've mentioned that many times before, it's dv dt. Velocity has the units meters per second and times second, so meters per square second. When does the object reach velocity of 31 meters per second? You simply put this equal to 31. You move this, make it positive 5, and 31, 36 divided by 4 is 9 seconds. A 180 degrees turkey is removed from the oven and placed in a 74 degrees Fahrenheit room. After 15 minutes, it has cooled to 136 degrees Fahrenheit. Find the general solution for T. As you recall, we discussed that the Newton's law of cooling, T of T is y sub 0, e to the power of kt plus T sub s, where y sub 0 is the difference between the two T sub 0 and T sub s. So what is a given? This is T sub 0. Originally, at time 0, the temperature for the turkey is 180 degrees. The surrounding, the room temperature is considered the surrounding, is 74 degrees. And then 15 minutes later, T of 15 is 136 degrees. This is the given. This is the translation of the question. And so with that in mind, we can use this y sub 0 is T sub 0 minus T sub s. which is 180 minus 74, making it 106. And into this formula, we're going to replace the y sub 0 with 106, t sub s with 74. In any order you put it is fine, as long as 106 is in front of e to the power of kt. And now we know this piece of information, so we are going to use this to find the k. Remember, this formula has everything except k is missing. So t of 15 is 136. So t of 15 is 106 e to the power of k times 15 plus 74, and it's 136. We are going to subtract 74 from both sides. We get 62. We are going to divide by 106. We get 62 over 106. I'm not going to even simplify it, although any fraction should be simplified. I just want you to see all the numbers as they appear before simplification. Now, in order to get to k, you take a natural log of both sides. When you do that, the left side becomes simply 15k. Now, the right side, if you divide it by 15, gives you the exact answer for k. Exact answer. You put it into a calculator with a bunch of decimals, and now t of t has this formula. 106 e to the power of negative 0.03575 t plus 74. And you really want to use a lot of decimals when you do that. How long does it take for the turkey to cool to 110 degrees Fahrenheit? So you replace t of t with 110 and you calculate the t, which again requires solving a logarithmic equation. So we are going to subtract 74 from both sides. We get 36. We're going to divide by 106. And again, I'm going to keep it in the format. I'm not going to simplify it because I want you to be exposed to each and every step just the way it's given, although it can be simplified. Now, if you take a natural log of both sides, the left side is just the exponent, negative 0.0357540, and the right side is this natural log. If you divide it by this number, negative 0.03575, you find the time. So divided by this number, and it gives you 30.2, or roughly about 30 minutes. So it takes 30 minutes to cool down to 110 degrees. A small rock is dropped into a lake. Circular ripples spread over the surface, with the radius of each circle increasing at a rate of 3/2 feet per second. Find the rate at which the area of a circle is changing when the radius is 4 feet. First, reminding everybody, here's the shape. The radius is this, diameter is 2 times that. You go around, it becomes a circumference 2 point r. If you want an area, the formula is pi r squared. In this case, we just need the area. So area is pi r squared. dr dt is 3/2 feet per second. We want to find the ADT when r is 4 feet. So this is the translation of this question, everybody. And so remember, t is the independent variable. You can think of dy dt as dy du du dt. So pi r squared, if you want to differentiate it, the pi remains as a coefficient or a multiply. So r squared becomes 2r dr dt, or 2 pi r dr dt. Replace the r with 4 feet, the r dt with 3/2 feet per second, and these two cancels out these two. You get 12 pi and an approximation is with a bunch of decimals, 37.6991 square feet per second. Units of the area over units of time. You always want to pay attention to the units when you're dealing with applications. Find the y dt for the equation. And of course, the moment you see the y dt, t is the independent variable, which means the derivative of x is no longer 1, but rather dx dt. So to differentiate this, we are going to go with the extended power rule. 4 sits in front. The same thing to the power of 3. And then the derivative of the inside is 5 dx dt plus dy dt. Minus x gives us minus dx dt, and any number results in 0. You could solve for dy dt, but because they want the evaluation, just plug in the numbers that are given. 10 minus 9 is 1, so to any power is 1, so this is 4. 5 times 3 is 15. So if I distribute, I get 60 plus 4 dy dt, negative 3 doesn't go away. And 60 and negative 3, they add up to 57. Moves to the other side, becomes negative 57 divided by 4, and that's the final answer. Dy dt is negative 57 divided by 4. A 20-foot ladder leans against a building. The base of the ladder slips away at a rate of 2 feet per minute. Find the rate of change of the height of the ladder when the base is 12 feet from the building. So applications, you must draw the settings so you can define your variable. So this is moving this way, creating this right triangle. This is moving down, and the ladder is fixed at 20 feet. That's the length of the ladder. As it moves this way, creates a speed or rate of dx dt equals 2 feet per minute. As it goes down, creates the speed or rate of dy dt that is missing. And so we know that dx dt is 2 feet per minute. And we want to find dy dt when the base is 12 feet from the building, when this distance x is 12 feet. And we should know a squared plus b squared equals c squared. So x squared plus y squared equals c squared. And c happened to be fixed at 2. Differentiate this with respect to t, 2x dx dt plus 2y dy dt, and that gives you 0, although everybody should know 20 squared is 400, but it makes no difference when you differentiate. Now you can plug in to find the missing dy dt, but we don't have the y. In order for you to find the y, you have to plug in x equals 12 into this Pythagorean theorem. Subtract 144, you get subtract 144 from 400, you get 256. And the root of that is plus minus 16. Only positive 16 is acceptable. Now you can plug in. 2 times 12 times 2 is 48. 2 times 16 is 32. Therefore, we get 48 plus 32 dy dt equals 0. We move the 48 and we divide both sides by 32. They are both divisible by 16. We get negative 3/2 feet per minute. As I mentioned it always, x is increasing, dx dt is positive, y is decreasing, dy dt must be negative, and it is. See, the rate of change is negative. If they say find the rate at which the height is decreasing, then you report it as if, because they said decreasing, you report it as positive. Falling sand is forming a cone-shaped pipe. The volume of a cone is increasing at a rate of 54 pi cubic inches per minute. The height of the cone is twice the radius of the base. Find the rate at which the radius changes when the radius is 6 inches. First and foremost, here's the shape. Again, you have to have the drawing to define your variables. Here's the R, here's the H, and you should know the volume is 1/3 pi r squared H. So here's the volume. This is dV dt, 54 pi cubic inches per minute. The height is twice the radius, so H is 2r. We want to find the rate at which the radius is changing, 1 dr dt, when r is 6 inches. So this is the translation of the entire thing. You need this with H and R to define your variables. Now, because we are interested in dr dt, and this has two variables, r and h, we're going to get rid of the h and replace it with 2r. If we were interested in dh dt, we would get rid of the r, which is h over 2, okay? So for now, h is 2r, which is elementary algebra. Now we find dv dt, and dv dt is 2/3 pi times now r cubed gives us 3r squared dr dt. This number 3 cancels out this, and it gives us 2 pi r squared dr dt. Now, dv dt is known, r is also known, and what is missing is dr dt. 6 squared is 36 times 2 makes it 72, so 72 pi dr dt. We are going to divide both sides of this equation by 72 pi, 72 pi. The pi's cancel out. Both of them are divisible by 18, 3 over 4 of an inch per minute. So as the volume is increasing by this much, the radius is increasing by this much. Positive means it's increasing, negative means decreasing. Use differentials to approximate square root of 27. First, we need a function that represents this operation. And all you have to just read it, square root of 27. So it's square root of x. Then choose a number x close to 27 for which the square root is easy to compute. The closest number would be 25 because square root of 25 is 5 and everybody should know. So f of x plus delta x is precisely f of x plus delta y. We're going to approximate it using dy. So f of x plus delta x is f of x plus dy. And delta x is 27 minus 25 is true. It's positive. So it's important to know. We're going to work with this because we can. And we're going to go from 25 to 27. It goes up by 2. If it was, for example, the square root of 24, this would be -1. And so what is f of x? We know it. What is dy? We don't know it. We have to find out. So first, we are going to differentiate this by rewriting this as x to the power 1/2. Its derivative is (1/2) x to the power of 1/2 minus 1, which makes it -1/2. Or 1 over 2 square root of x. So what is dy? dy is the same thing times dx. Same thing times dx. And so now we're going to replace everything. We're going to replace f of x with square root of x, and dy is 1 over 2 square root of x dx. We are in business. Square root of 27 means f of 27 means f of 25 plus 2 means replace the x with 25 and dx with 2. Everybody knows square root of 25 is 5, so this is 5. These 2 cancels out these 2, 1 over 5. 5 and 1/5 or 5.2. Now, if you look at the result from the calculator, of course, with a bunch of decimals, if you were to stop at 1, we would change it to 2, become identical. That's how close they are. Now, as you recall, linearization means finding the tangent line. So you don't have to memorize any of this formula. Just find the tangent line for this function at this point. So the pair is 25 and 5. 25 plug in, you get 5. The slope, remember, when you plug it into this, becomes the slope. 25 into this gives you 1 over 10. So again, 25 and 5, m is 1 over 10. So y minus y1, that means y minus 5 equals m, that means 1 over 10, x minus x of 1, that means 25. And you do the process, you get to this one. If you replace the x with 27 because you want L of 27, you will get the same answer. And you're more than welcome to check it out. ddx of sinh 10x squared. Well, reminding you of the hyperbolic functions, the derivative of sinh is cosh is sinh, hyperbolic tangent is hyperbolic secant squared, so on and so forth. So the derivative of sinh is cosh, and by the chain rule, so cosh of what? First of all, cosh, and by the way, just the way you did it with the trigonometric functions, you can just say sinh and stop, pause, the answer is cosh. But you must have some sort of argument, or it's the same argument, 10x squared. Now, by the chain rule, we need the derivative of 10x squared, which is 20x. We put it in front, we are done. Now, the same thing here, cosh, just like sinusoidal functions, we are going to say cosh and pause. The answer is sinh. Remember, the derivative of sine is cosine, the derivative of cosine is negative sine, but that's not how it works with hyperbolic sine and cosine. Hyperbolic cosine also it's positive sinh. And then you have to put its argument. And then square root of x, by now, you know, it's x to the power of 1/2, and you know its derivative is 1/2 x to the power of negative 1/2, or 1 over 2 square root of x. By now, we should know that. We've done it. But that's fine. It's a good practice to show it. And you rewrite it as sinh square root of x over 2 square root of x as the final answer. F of x is hyperbolic tangent of 1 plus e to the power of 2x. So again, hyperbolic tangent. The answer is hyperbolic secant squared. Then you need the same argument. And by the chain rule, you need the derivative of this argument, which is e to the power of 2x times 2. And you just rewrite it. Find the absolute max and mean on the given interval, f of x equals x squared minus 1 quantity cubed, the interval of negative 1 to 2. Well, you're dealing with a polynomial function. It's a closed interval theorem. And this is continuous from negative to positive infinity. Therefore, it makes it continuous from negative 1 to 2. By the way, this is polynomial of degree 2 times 3, or 6. So we are going to find CPs by finding the derivative. So 3 times x squared minus 1 quantity squared times the derivative of the inside 2x. And because we want to find the CPs, we're going to set this equal to 0. And I hope you recognize if you set this equal to 0, this gives you x squared minus 1 equals 0, which is plus minus 1, and this gives you 0. Now, is negative 1 in between? It's one of the endpoints. You can use it. Is 0 in between? Is 1 in between? Yes. Excuse me. We're going to evaluate the function at the endpoints and the critical points. So just for the sake of argument, if you plug in negative 1, you get positive 1 minus 1 makes it 0 cubed. So this gives you 0, so does 1. So this 2 gives you 0. If you plug in 0, this goes away. Negative 1 cubed gives you negative 1. If you plug in 2, 4 minus 1, 3 cubed is 27. So those are easy evaluations. Absolute max, absolute mean, and we write it in this fashion. Absolute max is 27. At 2 comma 27, absolute mean is negative 1. At 0 comma negative 1. The mean value theorem, given f of x equals 5 minus 4 over x, find all c in the interval of 1 to 4 such that the slope of a secant line equals the slope of a tangent line. Here's the mean value theorem. If f is a continuous function in the closed interval of a to b and differentiable in the open interval of a to b, there is a number c in a and b such that in the interval of a to b such that f prime of c is f of b minus f of a over b minus a, or you can use the cross product. Now, what is this function? This is a rational function. And a rational function, the domain is all real numbers except what makes the denominator 0. So all real numbers except 0. So here's the graph we wanted. Here's the 1, here's the 4. And the idea is that if you connect those two, because it's continuous, then there is somewhere in between that we have a tangent line. This is a secant line that is parallel to that. That's the idea. And this one has an x coordinate, which we don't know, we are looking to find. That's the idea behind this, the mean value theorem. So this is a rational function. So it's continuous from negative to positive infinity, except at 0. Therefore, it's continuous from 1 to 4. So if it's continuous from negative infinity to 0, union 0 to infinity, but we just want from 1 to 4. And therefore, it makes it continuous from 1 to 4 and differentiable from 1 to 4. Again, there's no discontinuity, no sharp corner. It makes it differentiable. Remember, we are not interested at the endpoints when it comes to differentiability. And therefore, we can calculate f prime of c is equals f of b minus f of a over b minus a. That means we are going to plug in a 4 and evaluate this, minus 1 and evaluate this. Now, if you plug in 4 here, class 4, this becomes 1. 5 minus 1 is 4. If I plug in 1 here, I get 4. 5 minus 4 is 1. So I get 4 minus 1 in the numerator. The denominator is also the same thing. It's 1. So f prime of c must be 1. Therefore, we are going to calculate f prime and set it equal to 1. And by now, you may know that the derivative of this one is 4 over x squared. I quickly show you. So f of x is 5 minus 4 x to the power of minus 1. So if I want f prime is minus 4 times minus 1 x to the power of minus 2, which is 4 x to the power of minus 2, or 4 over x squared. And this must be equal to 1. So it makes x squared equals to 4. It makes x plus minus 2. There are two answers. However, between 1 and 4, the answer must be positive 2 only. Again, there are two answers. Okay. As it appears, at negative 2, in fact, here, we have also another secant line, but we want it to be between 1 and 4, and that makes it positive 2 only. And I remind you the Rhodes theorem. The Rhodes theorem is very similar to that. F is continuous on the closed interval of A to B, F is differentiable on the open interval of A to B, and F of A equals F of B, then there is C that belongs to A and B such that F prime equal to 0. Class, this is a special case of a mean value theorem. That's why it has one extra part. F of A must be equal to F over B. As you can see, F of A and F of B are two different values here. Find the limit. You can use any method. One method that has been discussed now, and you can use it, it's L'Hopital's rule. But you cannot use L'Hopital's rule unless you prove the answer is 0 over 0 or infinity over infinity. If I put 1, I get ln 1 over 1 minus 1, which makes it 0 over 0. Now I can use L'Hopital's rule, and the notation is h. The derivative of the top is 1 over x, the bottom is 1. And so you get the limit of 1 over x as x approaches 1. And if you plug in, you get 1. So again, this is extremely important. You have to prove that. What about this one? If you plug in, and let me quickly show you because you have to show work. If I plug in, you get e to the power of 0 minus e to the power of 0 minus 2 times 0 over 0 minus sine 0. And I hope you see that these two cancel each other, right? So we get 0 over 0. Therefore, we can use L'Hopital's rule. Now, to use the L'Hopital's rule, the derivative of this guy is itself. This is minus and minus plus e to the power minus x. This is negative 2. This is 1 minus cosine x. If you plug in, you get 1 and 1. 2 minus 2 is 0. 1 minus cosine of 0 is 1 minus 1 or 0. So you have to show it's 0 over 0. So we're going to do it again. This gives me itself, and this gives me minus e to the power minus x. 1 minus cosine gives me negative sign. With this negative becomes positive sine x. Let's plug in. If I replace it with 0, e to the power of 0 minus e to the power of 0 is 0. Sine of 0 is 0. L'Hopital's rule again. This is e to the power of x. This is plus e to the power minus x, and this is cosine x. Now, if you plug in 0, you get e to the power of 0 plus e to the power of 0 over cosine of 0. And it's 1 plus 1 over 1. That makes it 2 over 1, or simply 2. This one, you plug in sine of pi over 2 is 1. 1 minus 1 is 0. Cosecant is 1 over sine of pi over 2. It's 1. So you don't have to use the L'Hopital's rule. And that's the idea. Check and recheck, everybody. Check and recheck. So when we plug in, remember cosecant is 1 over sine. So when you replace the theta with pi over 2, this is 1, this is 1. So you get 0 over 1. So in other words, don't assume you get 0 over 0. Indeterminate type of infinity minus infinity. Try to convert the difference into a quotient by using a common denominator, or rationalizing, or factoring out a common factor, so that we have an indeterminate form of 0 over 0, infinity over infinity. Remember, to use L'Hopital's rule, you can only use it when you prove it's 0 over 0 or infinity over infinity. So therefore, you have to make sure that you can make the change. For example, in this case, if I want to find the limit, if I plug in cosecant, remember, is 1 over sine, and sine of 0 is 0 on the right side. This makes it positive infinity. Cotangent from the right, if you remember the graph, is also infinity. So you have infinity minus infinity, and we are going to take a common denominator by writing this as 1 over sine and this one as cosine over sine. So common denominator is sine, the numerator is 1 minus cosine, and if I replace the x with 0, I get 1 minus cosine 0 over sine 0. Cosine of 0 is 1, so this is 0 over 0. Now I can use L'Hopital's rule, and so I take the derivative of the top, minus cosine gives me positive sine, and sine gives me cosine. Now if I plug in 0, sine of 0 is 0, cosine of 0 is 1, so I get 0 over 1. It's important to know if I plug in, I get 0 over 1, which is 0. ln of x to the power of 7 minus 1 minus ln of x to the power of 5 minus 1, and 1 is x is approaching 1 from the right. I hope you notice this becomes 0, this becomes 0, but it's from the right. So this is negative infinity, so is this one. So minus infinity minus negative infinity is the same as infinity minus infinity in essence. So the technique is to combine these two into a single log, ln of x to the power of 7 minus 1 over x to the power of 5 minus 1. We can interchange the ln and limit. And this, as x approaches 1 from the right, if I plug in, I get 0 over 0. And so for this part, I'm going to use L'Hopital's rule. So ln remains. Limit as x approaches 1 from the right, this becomes 7x to the power of 6, this becomes 5x to the power of 4. And I hope you recognize if I replace the x with 1, I get 7 over 5. So ln of 7 over 5. Again, this part, when you plug in, you get 7 over 5. Use Newton's method to approximate the 8 root of 500 to 8 decimal places. Recall x, and it really comes from linearization from a tangent line. X sub n plus 1 is x sub n minus f of x sub n over f prime of x sub n. When it gets involved, I've given you this little programming. So if x is the 8th root of 500, then raise it to the power of 8. X to the power of 8 is 500, and f of x becomes x to the power of 8 minus 500. So you have to show your f of x as well as f prime, which is 8x to the power of 7. So that's the part that we have to work to show our readers the function and its derivative. Now, according to this formula, then, we have this one, and we're going to start with something. 2 to the power of 8 is 256, 3 to the power of 8 is 65, 61. You can go with 2. Don't start with something that is, decimal or fraction. That makes it difficult. The reason why, because now you can use calculator, but you have to show work. So what is x sub 2? Okay, so we start with x sub 1 equals 2. Continue until we agree to 8 decimal places. So using this formula now, x sub 1 is 2, replace it here, x sub 1 with 2. So this one and this one, you do the math, you end up with, when x sub 1 is 2, you end up with this. See, this is exact, okay? So 2 and 244 divided by 10 to 4, you can reduce it, and this is the decimal representation. We want to approximate it to 8 decimals, so we write a bunch of decimals. At this point, you can use the technology because the number is pretty involved. But you've shown all your work that you need to show. Now, we put into y sub 1 the function f of x, and into y sub 2 the function f prime of x. We store the first number x sub 1, 2 into x, we enter it, and then x minus y1 over y2, because this is f of x, and you press enter, enter, and you continue. And notice we want up to 8 decimals. Look at this one, 1, 2, 3, 4, 5, 6, 7. The 8th one is here, so 1, 2, 3, 4, 5, 6, 7. Look at the 8th one, 27, 27. In fact, one after that is 6. Because we want 8 decimals, I'm going to count it one more time. 1, 2, 3, 4, 5, 6, 7, 8. We want to start here, but next to it is 6, so this goes up to 8. So the answer would be this one, but 7 changes to 8. Please understand, 7 must change to 8. So 2.174555928. Use the left endpoints, right endpoints, and midpoints rules with n equals 5 to approximate the integral of 1 to 2 1 over x dx. And here's the rules, which is really the summation that is known as a Riemann sum. A is approximated by I going from 1 to an f of x by delta x, f of x of 1 times delta x all the way to f of x sub n times delta x. Now, for the left endpoints, we use f of x sub 0 all the way to the one before that. For the right endpoints, we use f of x sub 1 to the last one. And for the midpoint, we use the midpoints. However, the fastest and easiest way is going to be the method that I'm going to show you. First and foremost, we're going to graph the function that f of x is 1 over x. Okay. And we want a equals 1, b equals 2. So we're going to go from 1 to 2. And that means we want this shaded region. So from 1 to 2, I'm going to use a line segment, and I make it large enough so we can see it. Okay. So delta x is b minus a over n, or 1 over 5 or 0.2. And here's the line segment that I'm talking about. So we're going to go from a equals 1 to b equals 2. I made it large enough so it becomes clear what we have. So delta x is 0.2. So add 0.2 or 1/5. So 1, 1.2, 1.4, 1.6, 1.8, all the way to 2. Now for the left end points, basically remember, for the left end points, you don't use that. You use delta x. Remember, this delta x, you can factor it out. Okay, this delta x, we can factor it out. 1 over x. So 1 over 1, 1 over 1.2, 1 over 1.4, 1 over 1.6, 1 over 1.8, and we add them up. That's for the left endpoints. For the right endpoints, everybody, we don't use this one. Notice what we use. Delta x is 1/5. 1 over, the first one is 1.2 because it's 1 over x. We are looking at this function, everybody. 1 over 1.4, 1 over 1.6, 1 over 1.8, and 1 over 2. Add them up, you have the answer with a bunch of decimals. Now the midpoints, you have to find the midpoint. So how do you do that? An easy way. Just find the first point. Between 1 and 1.2 is 1.1. Then just add the delta x, 1.3. Or just 1.4 and 1.6, add them up, divide by 2, it becomes 1.5. Or just add delta x. So this is what? 1.7. 1.9. And m sub 5 gives you the approximation for this. F of what? Get all of this. 1.1, 1.3, 1.5, 1. So it's very easy if you draw a line segment and come up with the left endpoints, the right endpoints, and so forth. And that is the better approximation. And by the way, as I did that before, I'm going to show you that this part is the same as this part, so it will speed up the process. Okay, everybody. Use geometry to evaluate the integral of -3 to 3 square root of 9 minus x squared dx. There is a way to do this in calculus too, but in calculus, when we're going to do this by geometry, we're going to do this by the concept of an area. Okay, so here's your function. Okay, square root of 9 minus x squared. Let's call it f of x, g of x, h of x, and it goes from 2 in the interval of -3 to 3. And we remember circles. If it's centered at 0, 0, the standard form is x squared plus y squared equals r squared. If it's not, x minus h quantity squared plus y minus k quantity squared equals r squared. So g of x or y, okay, so these are the equations we should know, is square root of 9 minus x squared. If I square both sides, I get, if I square both sides, I get y squared equals 9 minus x squared. X squared plus y squared equals 9. What is that? It's a circle centered at 0, 0 with the radius 3. So this is a circle. This is a circle, but this is a semicircle. So the graph of G is a semicircle of radius 3. So we know the area is pi r squared for the circle. For half of it is half of that. So half of pi r squared, which makes it 9 pi over 2 as the final answer for the area of this shape. Using geometry to evaluate this integral.